Now before I start on the paper, I just want to do a quick word about our calculators. Okay, we have a range there, and you know, they vary. So this is the Casio where most of us are used to. Okay, this is the Sharp, which, while it's still scientific, loses out in a lot of ways. We don't have the double line display, you can't see what you've just done, but what we do have is a simple readout. We don't need to press the SD button for this one. Okay, so it does the job, but be aware that functions are in different places. Now be careful. Okay, as with the Casio, the functions, the second functions are written above it, so if there's something we need, we might just need to search for it a little bit more. For instance, if we want pi, we have to press second function, and this time we press the EXP button because there's our pi. We press that and we get pi up. Okay, so just be careful with that one. Now the main reason I mention these at the moment is if we need to reset, because if you've not brought your own calculator, chances are someone else has used it before you, and people like to mess around and press buttons. And sometimes it's nice to be able to reset it, because I can guarantee your invigilator probably doesn't know how. Okay. With the Sharp, it's nice and easy. There's a reset button, and all we do is we can just put a pen in there, and we press it, and it clicks, and you see the screen blink, and that's it. It's reset. Okay. Don't press too hard. Obviously, we'll break things, and we don't want to do that. Okay. The Casio, the reset is in the yellow, just above there. Okay. So what you do is you press Shift and 9, and we get the menu up, and we can reset data, memory, or initialize all. I would always initialize all, and then it says we've got, if we look at there, we've got equals for yes, and then we can press AC, and that is now reset. Okay, and that will do everything the way it's supposed to do. On the new Casio, which exams have bought a lot of, we haven't got that reset. What it is, it's under settings. And if we go on settings and our menu comes up and we just scroll down to reset, press the center button, it gives us the similar kind of choice. So we go to initialize all, and we can say yes. So we can press XE, basically the equals button at the bottom. I'll just move that up so you can see that. And that does it, and it takes it back to the home menu, and we just click on calculate, and that is it. We are back to normal. Okay. The other main ones, like I've mentioned, is some of the functions are in slightly different places. So like we said, on the Sharp, we press second function and EXP to get pi. On this Casio, we press Shift and then the times 10x button at the bottom, because we can see the pi symbol there, and we get pi there. On this Casio, just to annoy us, the pi symbol is over the 7. Okay, same kind of thing. This time we press Shift and we press 7, and we get our pi there. Okay, so that's similar kind of things for us. I know we've mentioned it before. Just going to clear each one of these. We've mentioned before about cube roots. Okay, now the Casio is the most simple. Cube root is just above the square root, so we press Shift and then cube root, and now we get the little 3 above it. Okay, and that is the correct way, because now we can type in our answer. We say, hang on, do that, do 27, and the cube root of 27 is 3. Nice and easy. Okay, on this one we've gone slightly differently. Okay, because while we've got the square root button there, it gives us the option. What they've done is they've simplified some of the buttons, so we still press Shift and then square root, but now we get a blank square. So now we put the 3 in, move to the side, then we can put our number in, and we get our answer there. Okay, on this one it's the same place, okay, above the square root. And on this one we would do 27 and then press that. Okay, so it's just the other way around. We put the number in and then we do the square root, the cube root function, unlike these where we put that in the first place. Okay, so we've had a look at pi, we've had a look at square roots, our sin, cos and tan, and the inverse. they're all in similar places. We can find those. And our fraction button, okay? Same again on the Casios, we've got fraction and then the mixed number. Press shift for that one. Same again here, so if I clear that off, if I press shift and the fraction button, I get my mixed number. Here I'm just going to press the fraction button so we know what we're getting. And effectively, on this one, there isn't that, okay? So if we were needed to work out a fraction of something, so for instance, our first question, we want a quarter of something, what we would have to do, instead of putting that in, we would put 1 divided by 4 to give us our decimal, and then we would multiply that by the number, okay? A little bit more long-winded, but it will get you to the same point, okay? So I'll go through a few more bits with the calculator as I go through the paper, but that's just a warm-up for us, okay? Hopefully that helps. And the other nice thing, of course, is remember to switch them off, save our batteries, that way they're there and they're working when we need them to, okay? All right. So, map 4, our mock assessment. As usual, don't forget to put your name on the paper. And of course, in the mock, we don't need to worry about centre number or candidate number, but we do for the exam, and that piece of paper will be on the desk when you sit down so you can fill those in. As usual, for this, we'd need a calculator. Hopefully you brought your own. If not, I hope you've got one that you know how to use. Mathematical instruments. Now, of course, that one, that just covers everything else, a geometry set basically, and formula sheet, which we include with every paper, and we keep showing you those ones so you know what you mean, okay? You just say black ink, use black ink, okay? Because they scan them in, we want to make sure that everything's covered. So, question 1. 1/4 of 780, okay? So for this one, because it's a calculator paper, all we need to do is to type in 1/4 multiplied by 780. And we're going to use our new Casio for these, in most cases for these, okay? So I can press the fraction button. Again, I always hope to turn the thing on. Where's the on button? There it is. Still getting used to these myself. So we've got 1/4, and we're going to multiply it by 780. And I get, straight up, I get 195. Okay, and there's my answer, 195. Only a 1 mark question. You didn't need to show that, but it's good enough to do. Okay. 1b, then work out the value of 19 squared. Okay, so we'll move that over so we can see everything. Clear that off. And in this case, I'm going to do 19 squared. That's it. Just type it in exactly as it looks, and I now get 361. Okay, so clear that off. And question 2, simplify fully. Y plus Y plus Y. So basically, don't forget, each single letter is one lot of Y. So I've got one lot of Y plus another lot of Y plus another lot of Y. So that gives me, altogether, I've got 3 lots of Y. Okay, so good enough so far. Over the page. And we have question 3. We know that 3 apples cost 96 pence, and we need to work out the total cost in pounds of 12 of these apples. Okay. Now, standard thing to do is to divide the 96 by 3 and then times it by the 12. Okay, and that is generally a good way of working. So if I do 96 divided by 3. Again, we'll show that on there. I'm going to do 96 divided by 3, and I get 32. So that's 32 pence per apple. Okay, and I can now do 32 times 12. So I've got my previous answer up, 32 times 12, and it now gives me 384 pence. Now, the sharper amongst you will have also spotted that 3 is a factor of 12. So all we actually needed to do, well, we know that there are 4 3s in there, so if I did 96 times 4, that would also give me 384 pence. Okay, so we've got 2 different methods depending on your route, but then basically we've got to be careful because it says work out the cost in pounds. Okay, so in pounds we've now got, we do take out 384. Because it's 100 pence in a pound, we divide that by 100, we move that decimal point 2 places, so we've got £3.84. Okay, and that's that first one done it for us. Okay, and then on to 3B. It wants to work out the cost of 4 cartons of apple juice and 2 cartons of orange juice, and we know that 40 cartons and 20 cartons of apple juice. So if we've got of apple juice, we've got 40, and we've got orange juice, we've got 20, and that equals £21.50. But we only need 4 cartons of apple and 2 of orange. So basically all we've done is we've divided by 10, haven't we? So all I do there is to divide by 10, and again I'm going to move that decimal point 1 place to the left, so that gives me £2.15. Okay, and I can put that up there, £2.15, and the pound sign's already on there. And it's a good point, that one as well, because the pound sign was on this previous question. That's how we knew we needed to change that into pounds. If you just leave it as 384 pence on that one, you'll lose marks. Okay, so that was that page. We can get rid of that. Question 4. We need to put these numbers in order of size. We start off with the smallest number. Now we've got negatives, and of course negatives below 0, they count as below. Okay, now if we had more than 1 negative, we would look for basically the lowest negative first, but in this case that's our first one. So we've got -1, 0, and then between these we've got 1.8 and 2. Okay, all crossed off. Nice and simple. The next one, however, isn't quite as simple. Okay, now with these we've got a mixed number and we've got a bunch of fractions. Okay, now we can change these all to equivalent fractions by finding the lowest common multiple of them all. I wouldn't waste my time with that one. It's a calculator paper. We can change them into decimals, all in the same format. We know what we're dealing with. So 1/2 is 0.5, 1/4 is 0.25, and these are ones we should know straight away, but if we don't, all we'd have to do is type in the fraction. So if I did 1/4, press that, it gives me 1/4, and at this point, good thing to show, we want to change that into a decimal. There's no SD button on this calculator, so we press format and then move the cursor down to decimal, and it gives us our 0.25. Okay, so I'll do the same now with our 7/8. Press format, down to decimal, and there we go. So that one gives us 0.875, and then our last one here is our mixed number. We've got 3 1/10. We're going to do just the same, but this time instead of just the fraction button, we're going to press shift and then the fraction button, and we've got our mixed number set up there. So I can put 3 1/10. When I press XE this time, first off it gives me it as a top heavy or improper fraction, 31/10. So now we can press format, down to decimal, and we get 3.1. Okay, so I'll move the calculator out of the way now, and we can now look at these, and we can see that when we look from the smallest, we've got 0.25, so 1/4 is the smallest, 1/2 at 0.5, 7/8 at 0.875, and our last one then is 3 1/10. Okay, and that will do us for that one. So that's question 4 done. Okay. Over the page, we've got composite bar charts. Okay, and the way these are, we've got so data for January, but we've got in one bar we've got walk and cycle. So what we can see is in January he cycled to school 15 times and he walked, when we go from 15 up to there, that goes up to 19, so that's another 4 times. So that means his total there is 19, 15 by cycle, 4 walking. Okay, if I have a look at this one, I've got 5, 10 and a 1, 2, so I've got 12 there, and then I've got 1, 2, 3 to there, and 1, 2, 3 there, so that gives me another 6, which adds up. 6 and 12, we've got 18, which it does, it matches across there. For March, we've got 12 days cycling again, but now we're actually going up to, we've got a total of 21, haven't we? Okay, and 21 take away 12 should leave us with 9. We've got 1, 2, 3 there, another 5 and a 1, so that gives us 9. April, lazy day, must have been Easter coming up, so we've only cycled 3 times. We've got a total of 10, and that means these must be 7. Okay, now you didn't have to do all of that, but it helps. Okay, so in January, how many days did he walk to school? Okay, and when we look at that there, walking to school, we know walk is the lighter grey in January, so 4 times. Okay, we're good with that one. And then it says, in which month did he cycle on twice as many days as he walked? Okay, so we're looking for the month where cycling is double. Okay, and here it is, it's February. Okay, they will accept just Feb, but you know, let's do these things right. Okay, and in May, Callum went to school on 20 days. He cycled on a quarter of these days, and he walked on the other days, and we need to show this information. So we know total of 20, 1/4 of 20. We can do same as usual. Some of you are screaming at the screen going, I know what this is. Don't worry, I'm just showing it anyway. So we've got 1/4 times 20, so that means he cycled on 5 days and he walked on the other days. 20 take away 5 leaves me with 15. So my first one is the cycling, which is the darker one. So I just need 5. Okay, 5 there, shaded in, and then the other one is our 15, and that we know comes up to 20. And there's our marks. Okay, we've got our shaded and we've got our lighter shade. Okay, now the main thing with this, to get the marks, we need that first one for cycling to be 5, the next one to be 15, the total to be 20, and of course an equal gap between the bars. Okay, so it looks neat and tidy. Obviously it doesn't look that neat and tidy, I drew it, but you get the idea. Okay, and that's a good question for us, that, because there's 4 marks available in total, and I think they were quite straightforward. Okay, so that's question 5 done. On to question 6. Paul leaves home at 7:15 a.m. and he travels to work in 20 minutes. And does he arrive by 7:30? So if I just add 20 minutes on to 7:15, okay, we've got basically 4 lots of 5, haven't we? So we've got from 7:15, we've got 7:20, 7:25, 7:30, 7:35. So from that, plus 20 minutes, we've now got 7:35. Okay, so no, he doesn't. Okay, and we can, when it says give a reason, it's explaining. And we can say that between 7:50, basically 20 minutes on from 7:15 is 7:35. We could say that there's only 15 minutes between 7:15 and 7:30, anything along those lines, but you have to be clear. Remember the idea. When you ask for a reason, treat it as if you're explaining this to an idiot. Okay, someone who doesn't know what they're doing. You have to be clear. If it's vague, you will lose the mark. Okay, if you just put not enough time, that won't do it. Okay, okay. So that was question 6. Question 7. So a timer's £20 and a notepad costs £1.30. Work out the greatest number of notepads you can buy. So we just need to see how many times that goes into that. So we do 20 divided by £1.30. Okay. Again, I'm going to shorten up. Actually, I'll do it the old way for this one. Just going to do 20 divided by £1.30. Now I don't really need the 0, I want to type it in, but I'm doing it just to show. And it gives us it as a fraction. So format, down to decimal, and we've got 15.38. Okay, I'm just going to do 2 decimal places, and of course this is all about rounding as well. The greatest number of pads he can buy, he can afford basically 15 and, well, 15 and a third we'll call it for the argument of it. It's not strictly true, but you get the idea. But we can't buy part of a pad, can we? So he can only buy 15 pads. Okay, so we want 2 marks. Basically, we want the working and we want the answer. Okay, so that was question 7. Now question 8, number machines. Now if you've been in my class, you'll have seen these plenty of times this year. We start off with an input. We have processors, so whatever the input is, we would times it by 2, we would add 3, and that gives us our output. Okay, so I'm just going to do it nice and quick there. You don't have to do this, I'm doing it to explain, scruffily of course, because that's my writing. So we need to work out the output when the input is 10. So we've got 10 times 2, which gives us 20, plus 3, we would have 23. Okay, like I say, it's 1 mark, we didn't need to do that, it's just follow the process, do the answer. Okay, and on this one, same idea, we have an input, we're going to times it by 2, then we're going to add 3, and we get an output. But this time, we need to work out the input, and we're given the output is 17. Okay, so to deal with this, we go backwards. We do 17, and instead of adding 3, we take away 3. So 17 take away 3 leaves us with 14, and then instead of timesing by 2, I'm going to divide by 2, and 14 divided by 2 gives me 7. So the input must be 7. 7 times 2 is 14, plus 3 gives us 17. Double checked, we know we're right. Okay, and that's good. Brilliant. So that's those done. Then we have a loaf of bread. And that's all good bread should be. We have a loaf and we've got a crust at either end. Probably the best bit of the loaf, but that might just be my personal opinion. Okay. 14 slices, each 12 millimeters thick, and 2 crusts, each 15 millimeters thick. Okay. And we need the total length of bread. Now the last bit, it says give your answer in centimeters, and it's there on the answer line as well. Be careful with that one, because it's a way to lose a mark. So we've got 14 slices, each 12 millimeters, so we do 14 times 12. Again, we're going to use that one. So I'll clear it all off. 14 times 12, and we get 168. So 168 millimeters, and then we've got 2 crusts at 15, so we're going to do 2 times 15. Now we can use a calculator for that, I don't need to. It's 2 times 15 we know is going to give us 30 millimeters. So then we can add those two together, and it's going to give me 198 millimeters. Okay, so there's 2 marks. But remember, we need to change our millimeters into centimeters. And there's 10 millimeters in each of those, so we divide it by 10. Now we're dividing by 10, we're taking our 198, and remember, if we're dividing by 10, we're moving that decimal point 1 place to the left. So we end up with 19.8 centimeters. Okay? And with our conversions, it's nice to see it. We can even just add in, just to make sure, we can say that 1 centimeter equals 10 millimeters. Remember that idea, we're explaining everything. We're telling them that we know that there's 10 millimeters in 1 centimeter. Okay? And on to question 10. We've got some algebra. And we've got a few algebra questions on here. So first step, we know that we've got something, which is the letter C. We're going to, and don't forget that line means divide, so we're going to divide it by 3, and we get our output this time, which is 15. So when we do the opposite, all we do is we do 15 times by 3. And on our wonderful calculators, we do 15 times by 3, and we get 45. Okay, so C equals 45, because 45 divided by 3 gives us 15. Okay. The next one is a little bit more complicated, more steps to this. Okay. So at the moment we've got a bracket. First thing you do, multiply out the bracket. Okay. Different methods for it. You can use the claw method, which is fine. I'm going to show with the grid. Okay. So we would put what's outside of the bracket there, and there I would put what's inside. So 2d minus 5. So we've got 4 times 2d, gives us 8d, and 4 times 5 is 20, but it's a positive times a negative, so that's a negative. Okay. So now we have 8 times d minus 20 equals 28. Okay. Now I'm going to show this the old method, but then I'll show it using the number machine as well. Okay. So first off, I need to add 20 to both sides. So they cancel out. I'm now left with 8d is now equal to 48. And then because it's 8 times d, I'm going to divide by 8 on both sides. Okay. And again, back to this. So I'll do 48 divided by 8, and again, answer of 6. So that means d must equal 6. Okay, and there's our answer for the line. Now the other method I've been showing this year is again using that number machine. Okay, so we start off with something. We have 2 processes. Okay, so in this case we start off with d. We're going to times it by 8, take away 20, and we would be left with 28. So same idea, I go backwards, I'm going to add 20, so that's going to give me 48 in the middle, and then instead of timesing by 8, I'm going to divide by 8, and 48 divided by 8, as we know, gives us 6. Okay, same idea, 2 different ways of showing it, and it depends on what you're more comfortable with. Okay, if you're still a bit shaky with working out solving equations, I like this as a method because it shows it just that little bit more clearly for us. And what it does is it moves the letter to one side, and we can just deal with the numbers, and that's what tells us what the letter is, rather than worrying about it in this format. Okay. So now question 11. These look suspiciously like number machines, just done in a slightly different way. Okay. So here it gives us a diagram, so we know that 4 plus 5 gives us 9. We add 3, we get 12. So we do the same thing. We're going to do 15, I'm going to move this over. We're going to do 15 plus 6.5, and that gives us 21.5. And then we're going to add 8. So we've still got the answer up on our screen. Add 8. We press Xe and then format, back down to decimal, and it gives us 29.5. Okay? And that's our process. Okay. So 2 marks, sorry, 1 mark on this one. As long as we've got both of those, we're good. This one is 2 marks because it's slightly different, because we've got missing things there and there. We're starting off with 5. I don't know what I'm adding because I don't know what I need to get in the middle. So I need to go backwards, okay? So I need to take away 11. Same again. So now I've got, clear that, 25, take away 11, and it gives me 14 in the middle, okay? And now, what I need to do, I need to find out what I'm adding to get to 14 from 5. So if I take 5 away from 14, I'll know the difference then, won't I? Okay. So I've still got my 14 up there from previous. I'm just going to take away my 5, and it leaves me with 9. And there's my the 2 marks for there. Okay. 5 plus 9 gives me 14, plus 11 gives me 25. Okay. Now, here we get a little bit more complicated. Okay. So when we look at this, we deal with, we've got A plus 3A. Now if we do A plus 3 lots of A, that gives us 4A. Okay. So what we're saying here is 4A equals 28. Okay. And then we're going to add another 2 lots of A to get our final answer. Okay. Now the first thing I need to do really, because if I do that, if I had 2 lots of A, basically I've got 2 lots of A added onto both sides, haven't I? Okay. But I think at the moment, because we want an actual answer, because we want the value, so we want the number, let's work out what A is. So we know 4 times A gives us 28, so the 4 lots of A. So I'm going to divide both sides by 4, and that means that A is equal to 7. So 28 divided by 4 gives us 7. So 2 lots of A will be 2 times 7, which gives us 14. 28 plus 14. Any guesses? So I'll do it properly. 28 plus 14, and we should get 42. Good answer. Okay. So we've got that one all sorted there. Well, it's like 42 as an answer, for those of you who read. Now, we have a list of numbers. It says work out the median. Okay. There's no easy way to do it. Let's just do the proper way. Median, we find the middle number. We have to put them in order first and make sure you count every number. So at the moment, our lowest is 2. So I'll put my 2 there and cross it out. That way I know it's been used. The next lowest is 6. And I'm putting a comma after each because I'm keeping them separate. We've now got 2 7s. So we'll make sure we put both down. Okay? We have to make sure of that. Then we've got 8. And as we carry on going up, I can see we've now got 10, 11, 12, and 18. Okay. Just a quick check. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I know we're good. Okay. And now what we do, we cross off first and last. 1, 2, 1, 2, 1, 2, and 1 and 2, which means all we have left in the middle is our number 8. Okay. And it was handy, that's this one, nice and straightforward, because there was an odd number of values, we knew we were going to end up with a single number in the middle. Remember, if you end up with 2 numbers in the middle, add them together and halve it to get your middle value. Okay, and that is question 12. So now we've got some patterns, and I know some of you don't like patterns. Okay, and now at this point in time, I'm looking out for my ruler and I can't find it, so I'm going to use the same thing that we all should use. I've got my ID badge. Okay. First question in this, draw the 2 lines of symmetry on this pattern. So what I'm looking for, and this is where we use our ruler, I'm looking for 2 points. I can do that. If I do that straight down the middle, I can see it's the same left and right, so I know I'm good there. Okay. If I do the same diagonally, it's not the same. But if I do the same horizontally, I can see again that it's there. Generally, if it says 2 lines of symmetry, we are going to be looking horizontal and vertical, okay? But always double check before you do it, all right? So then, same pattern, but this time they want us to shade 4 more squares so that the pattern has a rotational order, symmetry of order 4. What that means is, as we turn the shape round, it must look the same, okay? So pretty much, I know we've got a square in the middle, 9 squares to make up a square in the middle, and then I've got these 4 either side. So if I want it to look the same, I need those 4 to be on the top and the bottom, okay? So if I do this, now again, be a bit more careful when you draw yours. You've got rollers, you've got straight edges, you've got your ID badges, you can do that, okay? And now, if I turn that shape, I can see 90 degrees, I've got the same shape, 180, I've got the same shape, 270 is the same shape, and back to our original, and that's our rotational order of 4. So there's my marks, okay? That's question 13. So 14, Venn diagrams. Now the advantage here is it's already filled in for us, so we're just reading the information from it. So we have all the people who work in a gym. In this circle, T are all the people who can work as a trainer, and in the other circle are all the people who can work in reception. And there is a crossover in the middle. They're the people who can work as a trainer and in reception, and that's it. How many people can work as a trainer and in reception? It's this one here, it's 3, okay? So then it says how many people can work in reception but not as a trainer, and what that means is this circle are the ones who can work as a trainer, so we wipe those out, and the ones who can work in reception but not as a trainer, there's only 12, okay? And then we look at the last one there, what fraction of all of the people can work as a trainer? So again, we cover that up, all of the people who can work, we've got 17 who can work just as a trainer and 3 who can work at trainer or reception. So we add those together to give us 20, and that's 20 out of the total, okay? So we have got our 17 plus our 3 plus our 12 plus the 5 who can't do either, not too sure what they do, okay? So we do 7 plus 3, I've got 10, plus that gives me 12, plus that gives me 17. So I've got 1 plus 1 plus 1, so that gives me 20 people out of 37, okay? And that's all they wanted. They wanted the total of all the people that can work as a trainer out of the total of people and shown as a fraction. And there's your 2 marks. Okay. And that's question 14 done. So now, bit of ratio thrown in. So to get to college, students either walk, cycle or travel by car. So I'm going to do walk, cycle or car. Now 3/8 of the students walk. Okay, so I can deal with that straight away. I'm going to do 3/8 times 120. Oh, hang on, what have I missed something off there? Clear that one. You know what, look, see how simple it is. Forgot to press the multiply. I thought I had, and that's how simple it is. So now I've got that, I've got 45. So 45 students walk, so we've got 45 there, out of 120. And it says the students who cycle to the students who travel by car is a ratio of 1 to 2. So for every one who cycles, 2 go by car. Okay. So what we know there, when we've got ratio 1 to 2, that's 3 parts in total, isn't it? Okay. We're going to come back to that now. So to find out how many I've got to share in that ratio, I need to take that away from there. So I'm going to do 120 take away 45, which leaves me with 75. So 120 take away 45 leaves me with 75. So don't forget, we're sharing these out in the ratio. I'm going to give you that whole thing in problem. We've got a ratio of 1 to 2, and we're going to share £75. So we're going to use our old friend Adam. So we add these. 1 plus 2 gives us 3, which we knew from before, 3 total. We now need to share the 75, so we're going to do 75 divided by 3. We've still got our answer up there, so I'm going to put that as a fraction. Again, 75 over 3, and it gives us 25. So that means each part of that will be 25. So we now come back to our original ratio of 1 to 2, and we times each one by 25. So we now get 25 to 50. And when we add those two together, 25 and 50, we get our original 75, which is good. But here it only wanted to know how many students travel by car. So we know there's 25 that cycle and 50 travel by car. So 50 is our answer. Okay, I'm just going to put a line around that one so they know that that's working and that's our answer. Okay, let's face it, if I practiced this, it'd all be tidy, wouldn't it? Okay, so question 16, it's to do with the car. Now, for those of you, again, being taught by me, we know that the value of the car depreciates, but I like the fact they haven't used that word this time. They've just said it decreases. So it's going to decrease by 15% in the first year and then 10% in the second year. Okay, now we can find 15% and take it away, then we can find 10% of that and take it away. I don't want to do that because it's a longer method. If we've got 15%, if we're taking away 15%, our percentages are always out of 100, aren't they? So 100 take away 15, and that leaves us. So that means 85% of the value is left. Okay? So basically what we're saying is the car still retains 85% of its value. And then in the second year, we're taking away 10% of that value. I could do it in the calculator, I'm not. And that means we've got 90% of the value left. Okay? Again, you don't have to show that part. I'm doing it just to be clear. So year one, we're going to take the original value of 8,600 and we're going to multiply that by the decimal version of that, or I could just show that as a fraction. Now 85% is always 85 out of 100. So I'm going to show like that. Okay, so 8,600 times by, and what did we say? We said 85 over 100, and that gives us £7,310, and that's its value at the end of the first year. Okay, so that becomes its value at the beginning of the second year. Now again, we're going to do basically finding 90% of that. Okay, and instead of showing it like this, you can do the same method. You can put 90 over 100, but if I know if I do 90 divided by 100, I'm going to get 0.9 as a decimal. Okay, so we do the same kind of thing. I've still got my answer up. Now what you can do, you can follow it on, but what I like to do is press answer, and it's our previous answer, the same thing, that's 7310, and we're going to times that by 0.9. Okay, and we should get 6,579, and that is its value at the end of that year. So 6,579. Okay. Okay. Question 17. And what they're asking is match the algebra to the correct description, and one has been done for us. So they've told us that A equals 4 times R plus 6. F, I think that looks like. T, possibly. I'm looking at it at a funny angle, is a formula. Don't need to worry about it, it's done. Okay. So now, we need to match up the other 4. Okay. Now as I look down, let's go with the simple things. If I look down here, I've got this symbol, okay, more than or less than, okay, and we know that's an inequality, okay. So what I need to do is draw a line up to there, and what that means is we've narrowed it down, haven't we? Now there's something weird here, okay. I'm going to possibly zoom in, but I'm going to just lift the page up, okay, so we can bring in on that one. That symbol there in the middle, it's like an equal sign, but there's 3, okay? And what that means, if you ever spot that, that is an identity, okay? So that leaves us with 2. Now with this one, we have an equal sign in the middle of it. If we have an equal sign, it means it's something we could solve, so that means it's an equation. And the last one then is 8, we've got 3L plus 8M, there's no equal sign, we can't solve it, so that is just an expression. If we ever find out what L or M is, we can solve it. Okay. Sorry. So someone has £25 to spend on game downloads, and he downloads 5 games, each costing £3.40, and we want what percentage of the £25 does he spend. Okay. So first we need to know how much he has spent. So we're going to do £3.40 times 5. And that gives us £17. Okay. So we spent £17 out of the 25. So what we do, we put that 17 over 25, and if we do 17 divided by 25, it's going to give us a decimal, and to change that decimal into a percentage, we times it by 100. Okay, so I'm just going to put that in exactly as it looks. Okay, so clear that. We've got 17 over 25 times by 100. Okay. Don't forget, this is the same way we work out your exam percentages. Your marks out of the total times it by 100, and in this case we get 68%. Okay, and our percentage sign is already on the answer line, so I only need to put 68. Now slightly different method, same idea though. We know we've got to spend 17 out of 25. If we make that out of 100, then we know our percentage, don't we? Okay, and 25, there's 4 25, so we're going to times that by 4. And if I clear that off, I do 17 times 4, lo and behold, I get 68, which means, again, 68%, because it's 68 out of 100, and a percentage is always out of 100. Okay. Now we got some graphs. Okay. So, table shows information about the number of houses with solar panels in a town, and this is by year. Okay. And the first 3 years have been done for us. So 17, 18, 19 have been done. So we plot the next 3. So in 2020 there's 210. Now when we look at the scale, there's 50 between each, but there's 5 squares. So that means each square goes up by 10. Okay. So for 2020 we do up to 200, and then we need another 10. So it's 1 square up from 200. 2021 is 275, so that's going to be halfway between 250 and 300. So if I move up to there, so it's halfway on a square, and 2022 is 350, nice and easy for us. Okay. So we're feeling all happy and smug with ourselves because we've plotted them, but don't forget when it says complete the graph, draw the line. Okay, if you don't draw the line, you will lose marks. And we join each one up. Now if you've noticed, it's almost a straight line, but it's not quite. Okay. Alright, and there's our 2 marks for the graph. And then B, it says use the graph to estimate the number of houses with solar panels in 2023. Now, normally when we're doing this on a graph and an estimate, we would find our number, we draw the line up, and we draw it across, and there's our estimate. Okay. But this one, it wants 2023, which hasn't been done. It's beyond our graph, isn't it? So we can do a rough estimate, can't we? We could even do it with that one. Okay. And pretty much, if I look at the upward trend, if I kind of follow that line, I reckon we're going to be about there. Okay. And I'm going to say 440. Okay, actually that one's 420. Okay, but the secret is with this, as long as you've got something within that range on this one, you're going to get the right answer. And it's down to having done the graph first. It's not one right answer, it's an estimate. That's all it's ever going to be. So I've put there, but the secret is as long as you're above 350 and you're below the 500, realistically you're going to get the marks. So I've gone for there. In fact, I'd have gone between 350 and 450, we're going to get the marks on that one. Okay. Okay, question 20. We've got a building in the shape of a cylinder, has a diameter of 40 meters and a height of 55. And on the centimeter grid, draw a plan of the building. And it says use a scale of 1 centimeter to 10 meters. Okay, so basically we know that this is going to be 4 centimeters across and 5.5 centimeters high. Okay, now I'm just going to zoom out a moment because it's a cylinder. And there's one I prepared earlier, not quite, but you get the idea. And there's our cylinder, and they're talking about elevations. Now a plan view is a bird's eye view. So what we do is we take that cylinder and we're looking directly down from the top. Okay? So all we're interested in is the circle at the top, not the height of it, just that. Okay, so let me move that out of the way and zoom back in. So we need a circle with a diameter of 4 centimeters. Now again, my drawings aren't brilliant, but you get the idea, don't you? Okay. When we look at that, remember each square is 1 centimeter. So we've got 1, 2, 3, 4 centimeters across, and it's a circle. It's not a brilliant circle, but it'll do. If you had a compass, you'd do a perfect one. but we'll settle for the best we can do. Okay. So over the page, we want on this centimetre grid, draw the front elevation of the building, same scale. Okay. So again, we'll come back to that idea. We've got our cylinder, and the front elevation is we are looking directly at it from the front. So all we're interested in is the height and the width of the shape, not the circle. We know it's 40 meters wide, 4 centimeters, and we know it's 55 meters tall, so that's 5.5 centimeters. Okay, so I can now draw that on the other page. Zoom back in. So we know it needs to be, I'm going to use a ruler now. I'm going to try and be smart. So we've got 1, 2, 3, 4 wide, okay? And again, it's 5.5 tall. So we're going to do 1, 2, 3, 4, 5.5. Okay. Draw in my bottom. And draw it in my top. Okay, see, I've gone off there. Doing it off the screen. That's because I was concentrating on the drawing. So remember, 5.5 centimeters. So we've got 1, 2, 3, 4, 5.5 centimeters. Doesn't matter where on the grid you draw these. Okay, as long as they're on the grid, that's all that mattered with them. So plan elevation is bird's eye. Front elevation is directly from the front. And if you ever ask for the side, then it'd be directly from one side. Okay. 21. Two rectangles have the same area, and we want to work out the ratio of perimeter A to perimeter B. So we're going to do it. So I'm just going to put A to B down there. Ready? So they have the same area, but we've got a missing value here, haven't we? Okay. So I'll do the first one. I've got 8 times 5. Okay. And 8 times 5, do it the easy way. 8 times 5, 40. So that means we've got 40 centimeters squared. And that means the other one must be the same as well, okay? Because it says the two rectangles have the same area, so that will be that. So something times 10 gives us 40. So we know that, should put a line down there, we know that something times 10 gives us 40. So I do the reverse, I do 40 divided by 10, and that means it must be 4. So my missing side here is 4. So is this one. If that's 10, that's 10. And on here, if that's 5, that's 5. And that must be 8. So the perimeters. For A, I've got 5 plus 8 plus 5 plus 8. And for B, I'm going to do 4 plus 10 plus 4 plus 10. Okay. So 5 plus 8 gives us 13. Then that gives us 18. And then that's going to give us, from 18, we are going, sorry, classroom interruptions. Give me a moment. So, do that calculator, nice and easy. 5 plus 8 plus 5 plus 8, and that gives us 26. And that's centimeters. And on the other one, clear that off, I've got 4 plus 10 plus 4 plus 10. It gives me 28. So my ratio is 26 to 28. And that will do me for my answer, 26 to 28. We could have it, we could have 13 to 14, but it didn't ask for the simplest version. Okay, so that's all right. That's good enough for us. Okay. So now we've got some rounding to do. Okay, it says to the nearest pound, Rosie has £12. And she wants to buy 6 drinks and each drink costs £1.89. So show that Rosie definitely has enough money to buy the 6 drinks. Okay. Now, firstly, we need to think about, to get to £12, it's basically, we can look at it as Edda intervals. The lowest we can have that would round up to £12 would be £11.50, because anything lower than that's going to round down to the next. So £11.50 or above rounds up to that. But on the other side of it, anything less than £12.50 would round down. £12.50 itself would round up. So that's why we use the symbols here. So anything less than £12.50 rounds down, and anything more than or equal to £11.50 rounds up. So that's the lowest amount. Okay? So then we need 6 drinks at £1.89. So 6 times £1.89. Bring our calculator back into play. So we've got, let's clear that off, 6 times £1.89, and we end up with £11.34. And then we can say that, well, we know that £11.34 is less than £11.50. Okay, so that's the lowest amount she could have. That rounds up to £12, and that's the amount it costs. So she's actually clear by 16 pence. Okay, and that's our one for there. Question 23. The total cost of a taxi ride is calculated by adding a fixed charge of £4 and a charge of £2 per mile. And we want a formula to work out the total cost of a journey of m miles. Okay. Now we know £2 per mile is 2 times m. And a fixed charge of £4, we're going to add 4. And of course, in algebra, when we're forming expressions, we don't use the multiply sign. So the cost would be 2 times the mile plus the fixed charge of £4. So if we had a 10-mile journey, we would do 2 times 10 to give us 20, plus the 4 would be £24. Okay. And that's good enough for that, for question 24. Sorry, 23. We are on to 24 now. Now this ratio. And the basics of it is, we've got 912 students, and this is the ratio of students to teachers, 15.2 to 1. Now we know we try and avoid decimals in a ratio, but when it's in this format of n to 1, we can have a decimal. We just need the number to the right down to 1. Okay, so what we can do is, we know if there's 912 students to teachers and the ratio is 15.2 students to 1 teacher, if I do 15.2, well, basically I need to see how many times that goes into 912. So 912 divided by 15.2. That gives me 60. Okay, so there must be 60 teachers. So we have got a ratio of 912 students to 60 teachers. Okay, but it says the number of students stays the same, but the number of teachers increases by 2. So now we've got students to teachers. We've got 912 students, but now we've got 62 teachers. Okay, and remember that idea. Whatever we do, we've got to get this number down to 1. Okay, so it has to be something to 1. Now to do that, to get 62 down to 1, I'm going to divide it by 62. which means I have to do the same. Divide by 62 on that side. So I'm going to take our 912 and I'm going to divide it by 62, and it gives me 14, I'm going to call it 14.7, okay? Depends how we round it, okay? Because that could also be 14.71 or 14.710 and so on, but I'm just going to go with 14.7. The reason I'm doing one decimal place, one, it's easy because of the 0, and also the original point was also just a one decimal place, okay? So clear that one. And part B, school trip, still with ratio. So on a school trip, one teacher is needed for every group of 10 or fewer students, and 72 students want to go on the trip. So she tries to work out how many teachers are needed. So she does 72 divided by 10 and ends up with 7.2, and that's 7.2 teachers. Now, as usual, when it comes to rounding, if it's something physical, the usual rounding rules don't apply. Now she has gone 7.2, that rounds down to 7, so we only need 7 teachers. But if it's a teacher for every 10, that means 7 teachers would only do 70 kids. That would mean 2 missing out. So what she did, she rounded down when she should have needed 8. She would need 8 teachers. So always that idea, if it's something absolutely physical, sometimes we've got to round up when the numbers say round down. Okay, that's question 24. Question 25. We're going to draw a triangle using these lines. We've got y equals x, x equals -2, and y equals 4. And we're going to write down the coordinates of the 3 vertices. Vertices are corners. The only time we see that word vertices is in maths. Vertices are corners. Okay. So what we're going to deal with, the first thing, y equals x. What that means is, whatever the x coordinate, y will be the same. So if x is 1, so is y. If x is 2, so is y. If x is 3, and so on. Okay. So I'm going to draw that line up there, and I really wish I brought a longer ruler, but you get the idea. What it does is it carves a perfect 45-degree line through our graph, because even then, if we look, if x was -5, so is y. It's equal to it. Okay. So then x equals -2. So if I come along the x-axis, I look at -2. Now if I put that there, it won't work for us. Okay. But what we do know, that if I draw a line through there now, okay, and I'm going to label that one x equals -2, because here that would be -2, 0, -2, 2, -2, 4, or -2, -4. Okay, so every line, every coordinate on that line, the value of x equals -2. Just going to scribble up on there as well, y equals x, so we know what we've done, and y equals 4 for the last one. I'm going to use a different pen again for this, see if it works. That's a good start. Y equals 4. So same idea. I'm going to call the y-axis to where it equals 4. I'm going to draw our line. And this is the line of y equals 4. Because here, that would be 0, 4. That would be -5, 4. That would be 6, 4. Okay. So now we need the coordinates of each of those points. Okay. So here we would have -2, 4. Here we would have 4, 4. And the last one down here will be -2, -2. Okay, and that's all 3 written in. Okay, 4 marks. And basically we're getting we'll be looking at marks for these, but also with this drawn. Okay. Okay, last question, question 26. Now some of you may notice a change in the lighting. I've had to move rooms just to finish this last paper. So this one, we have got a sphere, or put it more correctly, a hemisphere. And what happens is people see that and that and they think, nah, not doing it. This is only worth 2 marks. And it says write down 2 mistakes. So we're critiquing, we're finding fault with the work that's being done. Now anything in a box like this is basically, it's going to be information. So we know the volume of a sphere, we do 4/3 times pi times the radius cubed, and that will give us the volume of a sphere. And of course for the hemisphere we would then halve it. So what she's done is she's done 4/3 times 7.5 times 3 divided by 2, halved it there to get 15. So the 2 mistakes, basically, simple one here, is she's done 7.5 times 3. 7.5 times 3 instead of cubing 7.5. Okay, we know that 7.5 cubed is the same as 7.5 times 7.5 times 7.5, not times in 7.5 by 3. Okay, and the last one, even though it's in terms of pi, she's not used pi at all anywhere. So she hasn't used pi in the calculation. Okay, well, I realise I've just written that off the screen, but you get the idea. Okay, and it seems like really obvious, that one, but it's 1 mark for each. Okay, so it's only 1 mark for each mistake. They don't have to be really complicated, it can be that simple. Okay, so you should have done 4/3 times pi times 7 cubed. So basically, let's write it up here next to it. We should have done 4/3 times pi times 7.5 cubed and then halved the whole thing. Okay, and that's what she should have done. So she didn't cube 7.5, she times it by 3, and she didn't use pi in the calculation. Okay, and that's that done. So hopefully by now this has been a bit of a help. We can sort it all out. Hopefully your feedback went well as well.